All right, so let's talk about system design. Some of the main questions that you want to ask yourself. Let me pull this thing over real quick. Here's some questions to think about. Are we building something new or are we refactoring an existing system? This last little bit isn't a question as much as our example that we're for the app that we're doing. Okay, so are we building something new or refactoring? Do we want a monolith or microservices? Let's talk about that a little bit too, and kind of the pros and cons of each of those. If you're doing microservices, or if there's anything more than just the one monolithic application, what pieces of the system will there be, and how will they communicate? How will they talk to each other? What data is each piece responsible for tracking? Okay, so those are some questions to think about. So, monolith versus microservices. This is a monolith. There isn't really a diagram. You have all of your code lives in one place. It runs as a unit. You have a database. It talks to each other. That's it. This is the simplest and easiest way to get going. If you're working at a startup that just wants to get some code out the door, honestly, do a monolith. Because let's look at what microservices would look like. And webhooks is one way to communicate between microservices. It's not the only way, and I'll show some other diagrams for other things. But in webhook is just a fancy word for an API endpoint. So if you decide to have three separate pieces of code, maybe you have all of your main application code here, maybe all of your product, anything related to products is going to live in a separate service, and notifications will be a separate service. That way, anywhere in your code, if you want to send a notification to a user, you just send a message to the notification service and say, here's a user, send a message to them. And the notification service knows how to send emails and texts and push notifications for mobile or whatever you have. The notification service keeps track of it all. It's all encapsulated in one area. None of the other services have to know how to do notifications. They don't have to think about it. They just send a message to the notification service and say, send a message to the user. And the notification service takes care of it. So with services, you end up with different pieces of your system are responsible for different either pieces of data or responsibilities like sending messages out, whatever it is. And then they can communicate with each other through webhooks, which is just a direct API call. Here, I'm going to hit this API and tell it to do something. Or you can communicate with queues, and there's other ways as well. We'll talk about a little bit about that. But you'll start to see that once you have microservices, you start to have all these different pieces of infrastructure that need to be set up. So with microservices, you start to have more infrastructure, and a lot of complexity comes in how these different infrastructure pieces exist. How do they communicate with each other? What are the networking rules? Like, not just what's our choice for how they're going to communicate, but how do they actually communicate? How do they talk to each other? Are there firewall rules we need to think about? There's a whole bunch of stuff that goes into this. So with a monolith, you don't have to think about any of that. With a microservice, let's say that you have a product design and you build a microservices around it, and then 2 weeks later, the CEO's like, hey, we got to change it. There's these huge changes. There's this huge market opportunity. We're going to do so much better if we pivot and do this other thing. You have all of these infrastructure pieces set up that suddenly you don't need anymore, or the communication patterns are different or something. It's harder to make changes quickly with microservices. So a monolith is really easy to just build quickly, change quickly. But when you start to scale, when you're just starting out, if you need to be able to pivot quickly and it's a startup, I think monolith's the way to go because you can get code done quickly, you can put it out quickly, it's easy. But let's say that you finally find market fit. People are willing to pay for your app. You can't change it willy-nilly anymore because people are paying for it. They rely on it doing things that it does. So you can add to it. Maybe you can make some changes, but you're not going to be changing things as drastically anymore. Because before you find market fit, before people are paying for it, you're trying everything in the book to try and get people to buy your software. Once people are paying for it, there's an expectation that's going to function a certain way. So monolith's great to get going. But once people start using it, you're not going to have changes as often. So now what? Well, as more and more people sign up and start using your application, you need to be able to scale. Okay, so there's vertical scaling and horizontal scaling. What does scale mean? Well, your server that your code is running on only has so much computing power. It only has so much RAM, only has so much CPU strength. It only has so much disk space. You have a certain amount of computing power and resources that you're limited to. So what happens when you have suddenly a really great ad campaign goes out and you have 10 times as many people signing up? What if that server can't handle that much traffic anymore and it just starts to get slow and bogged down? Well, you can scale vertically, meaning you just make the machine more beefy. You buy more RAM, you buy a better CPU, and if this is a cloud server, like if you're signed up on an EC2 on Amazon, or if you have like a DigitalOcean droplet or something, you can just go like increase the provisioning and say, well, I want twice as much RAM. And suddenly everything's fine and your server can handle the traffic again. Well, what if 10 times that many people come and sign up? Like, you can only scale vertically so far. Eventually you get to a point where you're using the best resources available that science has to offer right now. You're on this massive machine that it can do a lot, but it does have a limit. So then what do? Well, horizontal scaling is saying, instead of making the one machine bigger and bigger until we cap out, let's just have multiple machines that all run the same code. And then you have a load balancer that sits in front of them. And as traffic comes in, the load balancer knows how busy each of those servers are. And so it can send new traffic to the least busy server. Oh, now this one's least busy. Let's send traffic here. And it keeps track of how busy each of the servers are. And the load balancer manages traffic to balance the load so that the servers stay relatively equal. And what happens if you have 8 servers behind a load balancer and all 8 servers max out? Well, you just add a 9th server or a 10th server or a 200th, as many as you need. You can keep adding servers. And so that's horizontal scaling, which in theory is infinite. Once you scale to a certain level, you start running into weird issues with how do you scale your database? What about your load balancer? Does that need to scale? You start running into issues, but you can scale to millions of users really easily, honestly, with either option. So don't feel constrained by that. With computer resources, with science has given us hard drives and CPUs capable of doing a lot of work. So you can have a monolithic application that scales just fine. But if you already have paying users and you're trying to refactor your system and you know that down the road you're going to hit 10 million, 20 million, 30 million users, it might be time to start thinking about using microservices instead, because they can scale horizontally. Well, I mean, you can scale a monolith horizontally. That I lied a little bit about that. You can have a monolithic application that runs on 5 different servers and the load balancer sends traffic. So you can scale horizontally with a monolith. But when you scale a monolith, you're scaling everything at once. What if you only send 5 emails a day, right? You have 10 million users and they do all kinds of stuff, but you just don't send that many emails. Well, with microservices, you can scale individual pieces of your system and other pieces can stay small. So in theory, you can scale as needed the pieces that need it. So maybe your main application sees a ton of traffic and you can scale that to have 10 servers, and your notification just needs the one server and you don't have to think about it. Maybe your product service is like 200. Maybe that's everybody uses your app just to interact with the products. And so maybe your product server is like, you need like 50 of those behind a load balancer. Who knows? But you can scale different pieces of your application at different rates, and you're not constrained. The other thing to think about is with code cleanliness. A monolithic application, especially once you get a big application that's doing a lot, you end up with a lot of code. And it can be really hard, especially for new engineers that are starting on the team, to learn their way around and figure out what's going on, just because there's so much code. With microservices, the complexity changes where each microservice can be small. You can have a small code base that just does one thing really well, and that service is really easy to understand. Anybody can get in there and find their way around. There's not much to it. But now you have, 10, 20, 30 services. And so now the complexity moves out of a ton of code in one place, and instead it moves to the infrastructure of wrapping your head around what are all the services, what do they do, and how do they communicate. And that's where the complexity moves. Is you have more complexity on your infrastructure level and wrapping your head around how that works, as compared to in a monolith, you just have a ton of code in one place, and the complexity would be that there's just a lot of code in one place. Also, with a lot of code in one place, it's harder to keep it organized and to maintain good coding patterns. So there's some trade-offs there, but that's the main discussion that you need to have between monolith and microservices. And a really easy decision, if you just need an easy decision, is are we small and do we need to pivot quickly? If we need to change things quickly and we don't have a lot of code, monolith is honestly the right answer. If you already have a lot of code and you need to scale and you're not going to pivot a lot, then microservices start to be easier to organize, at least in my opinion. So now if you decide to go with microservices and you know, maybe you've figured out, okay, here's our services that we're going to have. We know what data each one's going to keep track of. But how are they going to communicate? You can communicate with webhooks, which we've talked about. It's just direct communication, server to server, API endpoints. Maybe you're using some kind of machine-to-machine token to authenticate requests to make sure that not just anybody is talking to that server. It's also probably a good idea, you know, any servers that don't need to be publicly accessible, don't make them publicly accessible. Keep them behind your firewall. So, you know, there's all these different steps you can take to make that work well. You could even have an API gateway that's publicly accessible that all public-facing apps talk to, and then the API gateway proxies to all of your services behind the firewall, and none of your services are directly publicly accessible. That offers a lot of benefits. You can have all of your permission checks in one place if you want. Well, you know, there's all kinds of things you could think about with that. But with services communicating with each other, a different thing you could do is a queue system. So instead of talking directly to each other, if this service needs to talk to this service, it just puts a message on its queue, and that will be processed when it's ready. That way, if the service goes down for a couple minutes, this service isn't down as well. It can keep doing what it needs to do, and sending messages to the queues of the other services. And when they come back online, they'll start handling those messages and taking care of things. With a queue system, instead of direct communication, there's a delay. So there's eventual consistency in your communication. So especially if once you have services, you're going to have replicated data. Let me give you an example. Maybe all of your users' information is stored in the main app database. So anytime user information needs to change, you'll talk to the main application code. It changes the application code or the user's information in the database. And then it sends messages out to anybody else who cares and says, hey, the user information changed. The notification database, when you want to send an email, the notification service, maybe it needs to grab the user's name to put it in the email. Like, hey, John, here's an email for you. Rather than having to reach out to the app database to get that information, like, hey, what's the user's name? It would just keep track of it in the notification database. So it would have little portions of the data replicated. So maybe the user's first name is John, and over here you would have a little tiny users table that just has like user ID, email, and first name or something. So that when you want to send an email to a certain individual, you can grab their email, you can grab their name, send it out. But what happens when he updates his name to Jonathan? Well, the app code would update that data in the database, and then it would send a message to the notification queue and say, some user information changed, here it is. And then once this service is ready to take care of that message, it'll pull it off the queue, it'll update its copy of the data in the notifications database to update the name to Jonathan for that user. So this is using queues. If you decide to use queues, you need to think about what happens with failed messages. You're going to need some kind of like dead letter queue is what they call it, where if a message fails, maybe you retry it a couple times. And if it fails 3 times in a row, you put it on the dead letter queue, which is basically an area that says, hey, for whatever reason, we couldn't process this message. It needs human intervention. Someone needs to go look at it and see what's going on. Now, if you have 15 services and the app needs to send an update to 8 of them, it's like you just send 8 calls out. In this pattern, you would. Another pattern would be to use topics that fan out to queues. So instead of the app sending 8 messages, it would send 1 message to its topic, and then any of these other services that care about data changes from app can subscribe to the app topic. So maybe the products queue subscribes to the app topic for shipping. Like if you have like a shipping address, right? That when you're looking at products, maybe it says this ships from Canada or this ships from wherever. So maybe if an address changes, it puts a message on the topic that says this is an address change, and maybe the product service subscribes to this topic for address changes, and maybe the notification service queue subscribes to this topic for user name changes or something. So queues can subscribe to topics, and so you send 1 message and that fans out to multiple queues, and then those queues are processed as they are ready. So these are a couple different patterns that I have personally seen used in my career, and maybe some pros and cons to think about as you decide what kind of system you are going to use. And I think, so just to touch on our example, just for simplicity, all the stuff I do, we're just going to go with a monolithic setup and pretend this is a new company trying to set up an app to get it out the door.